So now we're going to review the substitution method for solving systems of equations. Remember, the equivalent forms method that we learned yesterday is a subset of the substitution method. For the substitution method, as you can see here, we have our definition, is when we substitute part of one equation into another in order to find the intersection point. Remember, when you're solving a system of equations, you're looking for where the two lines intersect. So we're using the substitution method to find that intersection point. The two things that you need to do when you are solving for a system of equations are as follows. First, you have to solve one equation for either x or y, or really any of the variables that you have. Then you must substitute this into the other equation to solve for the opposite variable. We are definitely going to do some examples so that you can see how this is done. If you need to, feel free to pause this video here before going on to the next slide. We are now going to look at two different examples. Again, these examples will be on the worksheet that you have for homework in dealing with substitution. The first example that we have is 2x minus y is equal to 0. The other example, or the other equation, is 3x plus 2y equals 7. Notice that if we tried to do this with the equivalent forms method, we would end up with some nasty fractions, or at least halves and thirds, depending on what variable you solve for, with that second equation. So we want to use a different method that may be easier for us to use. Let's go ahead and solve this first equation up here for y. To get y by itself, I can simply add y to both sides. So I started with 2x minus y is equal to 0. If I add y to both sides, I get that 2x equals y. Technically, I have y all by itself right here. So I'm done. I did the first step of substitution where I solve for one variable. Now, the second step of substitution is substituting this part in for y in the second equation. So we have 3x plus 2. Now I need to replace this y with what y it represents over here. So I'm replacing y with 2x. I know that that has to equal 7. So I took the 2x here and I substituted it in for this y. Now, if I simplify, I see that I have 3x plus 2 times 2x is 4x equals 7. If I add these two together, I get 7x is 7. Divide both sides by 7 to get x equals 1. Awesome, we solved for one variable. Now I can go back to our 3 steps for solving any systems of equations where I need to plug this back into one of the original equations. Again, it doesn't matter which one, because we're going to use the other one for our check step. I'll just plug it into the top one. If I plug it into the top one, I'm going to have 2 times 1, because we know x is 1, minus y equals 0. So I have 2 minus y equals 0. If I were to add y to both sides, I see that 2 has to equal y. Therefore, these two lines will intersect at the point 1, 2. If you were to graph these two lines, they should intersect at that point. Let's double check by doing our check step. We plug these into the opposite equation that we have not used yet, so the second equation. 3 times 1 plus 2 times 2 equals 7. Well, 3 plus 4 does indeed equal 7, so it checks. Let's do one more example. For our next example, let's go ahead and use these two equations. We will do negative y is equal to negative 2x plus 3, and we can do 3x minus y equals 4. That top equation almost has y by itself, but unfortunately, there's a negative sign in front. We've learned how we can easily get rid of negative signs simply by either multiplying or dividing the entire thing by negative 1. So I'm going to multiply the entire thing by negative 1. If I do that, I get positive y is equal to positive 2x minus 3. So now, I'm going to take this part here for y and substitute it in for this y here. So I get 3x minus, you should always put your substitution expressions in parentheses. This way you don't forget to distribute anything that you may need to. So we're going to subtract 2x minus 3, and we know that that has to equal 4. Be careful, this negative sign, if you need to, you can draw on a 1 here to know that it's like a negative 1 being multiplied by both. So really this is 3x minus 2x, and negative 1 times negative 3 is a positive 3 is equal to 4. If I combine like terms on the left-hand side, I'm going to get x plus 3 equals 4. So when I subtract 3 from both sides, I see that x has to be 1. Halfway there, all we need to do is solve for y. So let's go ahead and plug this back in. I'm going to plug it into the original equation, the first equation for negative y equals negative 2x plus 3. So I have negative y equals negative 2 times 1, because we just found x equals 1, plus 3. Therefore, negative y equals negative 2 plus 3, and we know that negative 2 plus 3 is a positive 1. So if we divide both sides by negative 1, we see that y has to be equal to negative 1. Therefore, these two lines should intersect at the point 1, comma, negative 1. Let's go ahead and do our check step to make sure. Using the second equation, we have 3 times 1 minus a negative 1 is equal to 4. Well, this is the same thing as 3 plus 1 equals 4, which is true. 4 does equal 4. So you just checked it.